Alright, as I promised in an earlier video, I'm specifically the video connecting a lightning detector to your smart home. What I'm going to describe today is how I had them in the wrong order. How I turned this into this. Okay, so to start off, well, what is this? This is a light meter. Okay, now most people know light meters from the photography world. A meter such as this was commonly used by photographers of all stripes. As the automation in cameras increased and auto exposure and integrated light meters and all that good stuff started getting into cameras, and especially obviously when we went to digital, the necessity of having a light meter like this decreased quite a bit. The reason being, cameras, they're pretty good at adjusting exposure, and even if you get it kind of wrong, it's pretty easy to correct it in post. The dynamic range on modern digital camera sensors is phenomenal. This is a light meter for photography, okay? This is a light meter just for more generic purposes, scientific purposes. Fundamentally, they do the exact same thing. They have a light sensor here of whatever type, and they print out a value based on the amount of light coming in. Now, a photography-based light meter like this one will tell you what exposure to set your camera at to get a good picture. Okay, so the number, I can't demonstrate it because the battery is dead, so I can't actually show the screen, but what it would show you is, you know, if you set this thing up so that you tell the meter that your camera is set to an ISO of 100, let's just say, and then you have to tell it what your shutter or aperture is set to, and it will tell you the corresponding value. So if you say you're shooting at f8 and you click the button and it says, okay, you're shooting at ISO 100, you're shooting at f8, that requires a shutter speed of 1/150th or whatever of a second, okay? So useful for photography, but outside of photography, not as useful. What is this? Well, this is functionally very much the same thing. It's simpler. This photography meter has some features. It can capture strobe strength and some things like that, which we don't need. Don't want to break that. Anyways, this, on the other hand, is a more scientific, well, I say scientific, but it gives, it's simpler. It gives a simple number in lux. Now, you can also select foot candle. I have it selected to lux. Actually, I don't know. I have to look it up. Is lux metric and foot candle imperial? Probably. Anyways, so what it tells you is a number. Right now, where this guy is looking, we're seeing 375 lux, roughly. Okay? So, I guess the question becomes, well, okay, that's nice. Why? Well, what's neat about having an Illuminance sensor on your smart home network is you can enable or disable automations based on illumination values, okay? So I actually bought a sensor that has an Illuminance sensor to it, and the problem with it is it goes up to 50 lux. It saturates at 50 lux. So the problem with that sensor and saturating at 50 lux is 50 lux is not much, okay? So, you know, right now, with my lighting here, I'm already at 370. If I point this out the window, it goes much higher. So that sensor is great for detecting nighttime, but what it's not great at is detecting, well, it's still daytime, but it's quite dark. So for my smart home, I wanted certain lights controlled by motion to turn on only when it was dark enough, right? So my garage, I want the garage lights to turn on when it's dark enough outside. And that sensor saturating at 50 didn't serve its purpose. It was dark enough outside, say twilight, that sensor would still say, well, there's still 50 lux, so you're still got light outside, but that wouldn't be good enough because my garage was pretty dark. So I wanted to build a light sensor. Well, I wanted a light sensor that saturated way higher than 50. Couldn't find one. So I decided to build one. Okay, that's where the Arduino. So underneath here is an Arduino. And hopefully I don't hurt myself doing this. Okay, so underneath here is an Arduino. It's just an Uno. You can use pretty much any Arduino you want. Your limitations with an Arduino such as an Uno is you have very limited memory in here, so your sketches have to be pretty small, but that's fine for my purposes. And on top of the Arduino, I needed a way to connect it to my network. Now, wireless is the default way that many people go. I don't like wireless for things that are connected all the time, simply because reliability can be an issue sometimes. I prefer hardwired. So I purchased this shield. Wrong ecosystem, sorry. This shield, this is just an Ethernet shield based on the W5100, I believe. Here's an Arduino with an Ethernet shield. What do you need? Well, the only other thing you really need is this. It's called an LDR, a light-dependent resistor. Okay, that's what's probably in here. It could be also a photodiode. I don't know. It doesn't really matter. Actually, it's most likely a photodiode. But the point is, you need a sensor that changes its output depending on amount of light. So then the problem became, okay, I have an LDR, but now how do I calibrate it, right? So what I did is I took my multimeter and I would go into various situations and see what resistance my LDR was showing and how many lux my light meter was showing. And by doing that, I produced this chart. Now what you can see here is that I have, for a certain resistance, I have a certain lux, right? And that's all you need. Using estimation in Excel, I created a graph because it's not a linear relationship, and that gave me an equation. And I did a few trials. What you have is a variable resistor depending on light level. What I did was created a voltage divider with that resistor, right? So you put 5 volts into this resistor and LDR, and out comes a voltage that varies depending on light level, okay? And part of the design of this was to determine what resistor would I use. And that's why you see these different values of resistance. That's what that's referring to, the other side of the voltage divider. Anyways, I chose 500 ohms. Well, actually, I chose 470 ohms because that's a standard value. And put all that information to Excel, gave me an equation. And if you look here on the right-hand column, you'll see the correspondence between what the equation says for a given voltage level and what my original calibration measurements were. And they're pretty close. Doesn't have to be perfect. Close enough. All right. So I took that and I built this. This is currently what's outside my house right now. It's actually a, I don't even know where it came from. It has been in my mechanics toolbox for probably a decade. It is a housing for a halogen bulb. Pretty waterproof. So I retrofitted it, put my LDR in there, I 3D printed a mount, and I have it hanging off my east trough, or gutter, depending on where in the world you're from. And I have that wired in to the Arduino. So all that sounds great. I have a voltage divider calibrated to the light meter. How do I get that onto my home network? So that's the next step. So the next step is I needed software. Okay. Now, as I mentioned in an earlier video, my smart home is based on Samsung SmartThings. I highly recommend it to people. It's a very turnkey solution. It is not local control almost universally. There's a few cases where you can do local, but it's mostly cloud-based, which people hate. But the integration is great. Integrates with Google Home fantastically. Most devices out there that have any sort of pedigree have SmartThings integration, and those that don't, because SmartThings is a very open API, community members have created handlers for almost every device you can think of. So somebody out there created a software stack for the Arduino with an Ethernet or with a network connection, be it wireless or Ethernet, that integrates into SmartThings. This is exceedingly cool. It's very, very, very feature rich. The amount of sensors they have covered is just tremendous. The amount of work done on this is just, I commend them. With this setup, you can create almost any sensor you can think of. Now, in my case, I just wanted an Illuminance sensor. The only problem with that is ST anything only outputs voltage for Illuminance. I don't remember offhand. Anyways, I modified it like this so that it would read the voltage from my voltage divider and then apply the equation Excel gave me for my calibration. And that outputs a value in lux. Here's an example of a current reading in my home. And here's some example of graphs that show over the course of a few days, you know, the sun rising and then falling and whatever. And you can actually tell from these graphs, for example, this one here, that this was a sunny day. It was a very, you know, a very quick rise. You can see these little, if you look carefully at the beginning of the rise, you can see a little dip. That's when the sun just happens to hit a part of my neighbor's house that shades the sensor slightly. So it's very sensitive. And you can actually see this the latest hump in these graphs, you can see is not as smooth and it doesn't go as high in some places. The reason for that is we had a bad thunderstorm that day. So you can see the immediate drop in the outside luminance, and then it comes back up as the storm passes, and blah. It's very, very cool. So from just a pure data geek perspective, which I am most certainly of, that's very neat. But the benefit of this is now I have a sensor that does not saturate on a full sunny day. I can differentiate between twilight and full sun, cloudy day, you know, partly cloudy day. I can differentiate all that. So that's been fantastic. With all that done, I now have, I put this into a little box. I mounted it outside under an overhang so it doesn't get wet. I wired it into my network. I must say the creator of ST Anything is fantastic. The amount of work that he's put in, they did a great job. So much so that I actually encountered a problem. There's something going on with my Arduino and Ethernet Shield combination that causes this thing to hang. I spent a lot of time trying to figure out exactly what it was. Couldn't do it, so I actually went onto the forum and I asked the person who created this, and they were exceedingly helpful. They duplicated my setup. Initially, they duplicated the problem I was having and came up with a solution. But it didn't fully solve my problem. It solved their problem. Weird. But the point is they also gave me hints and ideas on how to deal with this or work around, because frankly, it doesn't have to be perfect. I just need to work. And what I ended up doing is in the code, I have basically after a certain number of reporting of luminance values, this thing will just reset itself. And that has eliminated the issue I was having. It's been working great for a couple months now, I think. So that's it. So what can you do with this? Well, in my example, I have exterior lighting in my house that I turn on for courtesy as the sun drops. So when I reach a certain lux value, I turn on this exterior lighting. That lighting is also motion sensitive based on a few different types of motion sensors, and that's gated by the illuminance value. So if it's more than a certain amount of lux, none of that automation happens. As I mentioned earlier, for my garage, if it's below a certain brightness outside, the garage lights turn on automatically when I enter based on a motion sensor. That does not happen if it's a full sun day or whatever. It's a fantastic value. Plus, it's pretty cool to see these graphs. I don't know. I find them quite fascinating. As always, any questions, any comments, I really appreciate it. There's been a few really nice comments on some of my other videos. I really appreciate that. And some good questions that actually prompted another video I quickly created. So thanks for that. That's all I got for now. Have a great day. Stay safe. Until next time.